Okay, so we're looking at the next part here, the logarithms. So we should also be able to sketch log graphs, just as we were able to sketch exponential graphs. Of course, we could use some coordinates, so we know that log of 1 is always 0, for example, and we could put the rest of the values into a calculator or work it out by some other means. That would be one way that we could draw it, and this is the general shape that we see. We're not over here. No negative x's because there were no negative y's with exponentials. So we cannot take a log and get sort of this negative x value here. Sorry, in other words, like we cannot do a log of a negative. A root of 1, an asymptote, again, like we have with exponentials, and this is a strictly increasing function. That means that the gradient is always positive. The easiest way, in my opinion, to remember how to draw this one is, because you probably will know an exponential better, well, you can just reflect it in the line y equals x and sort of derive the shape there. Laws of logs then. So there are a few laws that we can use with logarithms, and we can use this to manipulate things and solve things and so on and so on. So here are the three main rules. So notice with all of these, they have to have the same base. Yeah, you have to have the same base. The same as if you had powers, you needed the same base to add them and subtract and so on. It's the same kind of thing here. So log of x plus log of y is the same as log of xy. In other words, log of a product, thinking of it backwards as well, is the same as log of one of the factors plus log of the other factor. It's the same sort of thing with subtraction. So log of x minus log of y is log of x over y. You know, there's a very good video on TL Maths you might want to have a look at, which talks about how to derive these in a bit more detail in relation to power rules. So similar things with log rules. The main use really that we use them for is if we have, say, x to the power of k, logs allow us to bring this down to the front, okay? In other words, it's going to let us solve equations now where we want to find out what is in the power. Before this, at GCSE, we had to just do this by trial and error. But by pulling this down, we have a way of finding out what it actually is. Special cases, so we talked about both of these earlier on. So what power of a is a? Well, it's 1. What power of a is 1? Well, the power of 0 would do that. And what we have here, this is just another case really of this one here. Instead of writing a fraction like 1 over x, you could write that as x to the minus 1. And then what you could do is you could pull it down to the front. The last one here, you're not expected to know, but it comes up in some of the other university entrance exams. Okay, right. So let's have a look at a few of these. So logs of the same base added together. There are no numbers in front. That's important. We can't do anything with any numbers in front. So log of one factor plus log of the other is log of the product. So we can multiply the 6 and the 7 together. So log base 3 of 42 is exactly the same. Here, log base 2 of 15, log base 2 of 3, we're subtracting. So when we subtract, we'll divide. So 15 over 3 is 5, and we get this one here. This one is not ready for us to use yet. So 2 log 5, 3. What we're going to have to do is do that pulling down in reverse. So we're going to push it up there to the power. So we're going to get log 5 equals 3 squared, for example. Okay. The other one, 3 log 5. So 3 log 5. You do the same as well. So, oops, that's the other way around. 3 log. No, it's 3 log, and then there's a 2. So you put the 3 up there. So you get log base 5 equals 2 cubed. Now, why do you do this? Because you need to just have log with no number in front if you want to use these rules. We've got a 9. We've got a 9 there, and we've got, what was that? We've got an 8. So we should have 72. So we change it into this form first by pushing these numbers up to the right as powers, and then you can use the addition rule, but you can't use it before. This one is sort of ready for us to do something with, but that again is a problem. So you push the 4 up there. So a half to the power of 4 would be 1 over 16. And because we're subtracting, we're going to get 3 over 1 over 16. So we should get 48. Yeah. Okay. So the main thing I would sort of point out at this point is you can't have numbers in front when you're going to do log rules. You need to move the numbers at the front to powers. A couple of misconceptions. So the rules that we've just looked at say if you have, let's call this base A, of, what could it be, of C plus log of the same base of D, then that becomes log A C D. Yeah, it was about a product can be expressed separately as factors, but you've got to add them together. So why does this not work? Well, here they've started off with this. This is fine. This goes together, but it doesn't give you that. It would be BC, wouldn't it? That's the whole point. It turns into the product. So what can we say here? There's no log of a sum. Yeah, there's no log of a sum. It's log of a product is the idea. This one over here. So what's the issue here? The issue on this is, yeah, it looks like they've pulled a 3 down, but this is not the same as this. Okay? In this situation, the 3 sits above the x. It sort of belongs to that. This thing, we're doing log 2 of x, and then we are cubing it. So this is incorrect. The way that it's written doesn't make sense here. So these would be how you would need to frame it instead. So like if you did have brackets, the cubed would need to be inside, or you could just have that without brackets at all. Some questions then. So we're going to manipulate to solve these kind of questions. So a common strategy is we use the rules that we just looked at to put things together, and then we're going to solve it. So manipulate to use the rules. A log base 10 of 4 is fine. This one needs some work. So 2 log 10 of x, you can move the 2 up. So that's the same as saying log 10 of x squared. Okay. Now I'm ready for them to go together. So I've got this, and I've got, what was the other one? Log base 10 of 4. So when they have the same base and there's no numbers at the front, when you add them together, it's the same as the product of those two factors. So log base 10 of 4x squared, and the right-hand side is equal to 2. So I combine the left-hand side to get this one here. And then I need to sort of use the inverses. You want to get to this x squared here, but the thing is being logged, if you will. So you need to undo that. I like to do this strategy, which is where you do 10 to the power of underneath on both sides. 10 to the power of and log 10 cancel each other out. So this line becomes 4x squared equals 10 to the power of 2. Well, that is 100, isn't it? X squared is 25. So it's tempting here to say x is plus or minus 5. However, you need to check both of your answers in the original. If you focus on this part here, the 2 doesn't really matter so much here. But if you try log 10 and you put these answers in, that one there is fine, so that's fine. But if you try putting in minus 5, it's not going to work because we said that you cannot have a log of a negative. So actually, x equals 5 is the only solution here. So we've got another situation where we're dealing with quadratics and we need to interpret the validity of our answers. So x equals 5 is the only answer we need to use here. You always need to go back and check the original equation you started with and see if it solves it, because that's the question. That's the equation that you're trying to solve in the first place. A neater example, a neater example here. So we have to check each value in the original equation. Pause the video and have a go at this one here. So it might get a little bit sort of complicated. It might feel like that when you're combining the logs, but keep with it. And it is a show that question, so you can sort of look ahead and get an idea of where things are going. Pause the video and have a go. And I'm assuming that you've done that. So the 2 goes to the power for this one here. when you subtract, just sort of, use more brackets, okay? So x plus 15 all squared on the top over x. It's tempting to expand this one out, but it's a good idea normally to wait until the log part is taken care of later on. How do you undo the log 2? Well, you would do 2 to the power of on both sides, which eliminates that and takes you to this line of working out. Move the x up, evaluate 2 to the 6, and so on, and you'll get this one here. Okay. Hence or otherwise solve the equation. Well, you need to get the x values now. It's only 2 marks, so it implies that you shouldn't be doing too much. Part A said show that. All of these things mean you need to work with your answer here. Okay, you need to work with this quadratic. Remember that when you get your values, you need to check these original logs here and see if they work. So 25 and 9, they're both positives, so they're probably okay. Just check them here. 25 plus 9 is positive. 9 plus 15 is positive. 25 plus 15, 40, and 9 plus 15, 24. Yeah, they'll both be positive, okay? Over here, this just takes the values, so there won't be any issues. They are both correct in this case. This takes you then to 14e. Some questions here use log rules, but other ones are going to use some. I think some of these just need you to evaluate the easier numerical ones from earlier. So have a go at these questions here using the rules. Remember, you can't have a number before. If there's a number, you need to move it to the power. Addition means product. Subtraction means, okay, that we need the quotient. We need to divide them. So assuming you've done that, these are the answers for the first part. And the second part. And these ones down here are sort of more exam style questions that you may wish to have a go at. So for example, this one here combines to give you 2x plus 1 over x. Log 2 of this equals 2. 2 to the power of on both sides. And you would work it forward that way. So that takes you up to 14e.